Hey champs, welcome back to all of you once again on your channel that is on JEE Physics Maniac. So today we are going to discuss a questions from rotation and that too on pure rolling. This question a little bit different question, not a very tough question but easy question. So definitely if you do these questions there will be a quick revision, and especially this question is destined to the beginners. So let us go through the question. That four identical cylinder rods each of mass m are welded at their ends to form a square, and the corners are then welded to a light metal hoop. When they are saying light metal hoop means by default we have to consider that it is not carrying any mass, right? So this hoop is basically massless. This hoop is massless, right? Fine. If the rigid assembly of rods and hoop is allowed to roll down the incline, determine the minimum value of coefficient of static friction which will prevent slipping. So basically we are going to discuss the case of pure rolling here. Okay, fine. So now here in this case you can see a elaborated diagram. Now in this diagram we can clearly see that the different components of the forces are being shown out here. In this direction we will definitely have the weight mg acting of the entire system. By default we are considering that at the center the entire gravity is acting, because due to symmetry the center of mass will lie here. This along the plane we have considered to be x-axis, and perpendicular to the inclined plane we have considered to the y-axis. This angle is theta, so normal reaction is acting through this point that is given as n, and it is coming down to the acceleration a. And little bit geometry application, this length of the cylinder bar will come to be r root 2, whereas this length perpendicular distance from here will become r by root 2. Anyway, so now let us frame as the equations. So in equations we will see that along y direction, since it is not jumping off, it is in pure rolling, so it is always maintaining contact because the point of contact is always at instantaneous rest. So by considering the fact along y direction ay equal to 0, so there are two forces, one is n and another force is 4 mg cos theta. So combinedly if I consider that these all four cylinder bars are replaced with a mass concentrated at the center of 4m, so this is 4 mg. So definitely in that direction the force component will be 4 mg cos theta. So n minus 4 mg cos theta equal to 0. So normal direction we got 4 mg cos theta. That's fine. After that, what we have to do, we have to consider the motion along x-axis. So the friction is acting in the upward direction as it is having a sliding tendency in the downward direction, and because of pure rolling the sliding has to be stopped. So along x direction we will write 4 mg sin theta minus f is equal to 4m into a. So now we will get the torque equation. So here in this case we know that friction is the only force which is providing the torque here about the center of mass. So tau is equal to I alpha. So F into R, friction force is acting along the horizontal inclined plane in this direction. So that is F into perpendicular distance R. This is the torque. Okay. So without much ambiguity you can understand this. Now here you have to calculate the moment of inertia of the system tactfully. Let us think about a single rod. For this rod about the center of mass we can write ml square by 12, where L is equal to obviously r root 2. L is equal to r root 2. Now this is about the center, about this axis. Now we have to shift by parallel axis theorem. So we'll get m into r by root 2 whole square into alpha. So after simplification F is equal to, we get 8 by 3 m into a. Right. Now if I substitute that in equation number 2, we will get a is equal to 3 by 5 g sin theta. Then furthermore we know F equal to mu into n, and from 4 we will get that mu is equal to 2 by 5 tan theta. Now this is a very simplistic kind of thing, but I will leave you with one question here that you have to think and let me know in the comment box. As we know that there is an alternative method, especially those who study JEE under the guided brick and mortar system, you know that we can apply the formula of n, mu is equal to c by 1 plus c into tan theta, where c is a constant. Here in this case we can see that I is coming to be 8 by 3 m into r square. So c is supposed to be 8 by 3. So if I substitute it here, that mu value will come 8 by 3 plus 1 plus 8 by 3 into tan theta. So in this case the value will become 8 by 3 into 3 by 11 into tan theta, which becomes 8 by 11 into tan theta. So in one case we got the answer to be 2 by 5 tan theta, but if I follow this shortcut trick I am getting the answer as 8 by 11 tan theta. So where we are going wrong here, that you have to identify me and let me know in the comment box. Till then, keep watching, keep sharing, and please help me to reach out to 1000 subscribers, and definitely I hope that I will continue this with you people. So bye bye till next video. Thank you.